Okay, so I will do the tutorial with you today. We'll work step by step. I will not solve the whole problem. I will only touch the major issue related to the modeling side. So this is my blank screen of the Abaqus, and I will create a part. I will name the part as the token, 2D planar, and the shell, right? So these are standard, and I will make the size about 100. It doesn't have to be 100, but that's what I chose. Okay, so this is the sketch window. Now I can sketch the section geometry. Let's see, I create first a circle, and then I say I create at the 0,0, and the radius, you can choose any point that you want. So let's say this is how I made it. Right now, this is a yellow circle, meaning the dimensions, nothing has been defined. So, but at least I know that I want to create everything at the starting from this point. So what can you do? The circle can be fully constrained if the center location is fixed and also the radius is fixed. Okay, so let me check. There are some messages. Okay, so that's the other questions are unrelated, so I will move on. All right, so what can I do? I will first assign the dimensions of the radius. So the radius of this one, let's say radius equal to 4. Okay, so I have the radius 4 circle, but still it's yellow, meaning the circle can fix the radius, but it can move. So what I do is I put the constraint. So this, if you can open the constraint here. Not to move it, okay. All right, there. So there are many different constraints, out of which I will choose the fix, meaning I will choose a point and then we'll fix the point. So if I choose this point, which is the center of the circle, okay, then now you see that your circle become a green circle, because then it means it's fully constrained. It is not allowed to move horizontally, vertically, and the radius is fixed. So it's fully constrained, and now the circle become green line. To put the dimensions, I need to have some sort of the construction line. So I will make, if you look at here, these are the construction lines, okay, horizontal and vertical. So I will create a horizontal construction line. This will not move because I created the line with respect to fix the point at the circle. So it will not move, it's already constrained. So that's why it looks like green. And I'll make the vertical one also at the center. So I have a horizontal construction line and a vertical construction line. Since the center of the circle is already fixed, that this line will not be moved, so I can provide the dimension with respect to this line, then everything will be relative to this point. Okay, let's make another circle. Okay, and then dimension of this one will be 5. So let's choose the dimension. This one will be 5. So basically, this will be the circle that on the left hole. Okay, now as when I provide the radius 5, it is automatically green because the center point is already fixed, right? So that's how we do. Now I move, and then I create another circle. Now when I create the circle, if I move along this construction line, okay, meaning if I create a point here, the point is fixed in vertical direction because it's on the construction line, but it's free to move horizontally. So the horizontal dimension is not fixed, but vertical dimension is fixed. So let's make 1 here, okay? All right, so what are the fixed? Only vertical dimension is fixed, right? So I will provide the dimensions between this center point to the horizontal line here. And then let's say dimension is 42. So I'll provide 42. That's the dimensions. Okay. So as you see, it moves left and right depending on the dimensions. And also I provide constraint or dimension on the radius. The radius will be inner one, so it will be 2.5. So again, as I said before, to define the circle, you need to have a fixed location of the center and the radius. Okay, so that the horizontal dimension is provided, 42 is fixed. Vertical one is fixed because it is on the construction line, and the radius is fixed, so this dimension is fully constrained. Make another one at the same locations, and then the dimension of this one will be 4.2, right? 4.2. So now I have all outline circles that are what I want to do. So these are basically the good dimension that I can start with. I will make another circle. Well, later, these are not full circle, these will be arc, but I start with a circle, okay? So let's make a circle here, okay? And this one, you need to provide horizontal and vertical locations. So I provide the dimension from this point to that point. So this is your dimensions. Let's say this is a 34.5. That's what is given in the project statement. And also vertical dimensions. Okay, vertical dimension is 6. And then radius, how much radius was it? Radius 3. Again, now this is also green, right? So because we fixed the location and we fixed the radius. Going forward, I can make another circle over here, and then provide the dimensions between this one to this line. Again, this will be 34.5, and then this will be 6, and then radius will be 3. Okay, and then we connect this one by a straight line. So I create a line. Don't worry about where you pick it, just pick somewhere close to where you want to start. And then you go again, somewhere that you want to connect it, okay, like this. Don't worry about how you do it from now on at this point. Just to draw the line, just to briefly sketch from here to there, okay? So that's what we want to do. Now, again, these lines are yellow, meaning it's not constrained. To have a fixed dimension of the line, the both locations has to be X and Y location of the two lines has to be fixed. So what I do is, well, my intention is no matter how I change it, it has to be tangent on here. So I will provide a tangent constraint between the circle and the line. Then as you can see, there will be parallel symbol over here, meaning they are tangent over here. I do the same for other side here. So I provide a tangent between this one and that one. See, it'll move the location depending on your geometry, where the line has to move to make a tangent. While you do this, now the line becomes green, meaning the geometry, the position of the line has been fixed because you have one tangent point here and the other tangent point over there. And I move the other part. Again, provide the tangency between straight line to the arc. So you have a new symbol here, not here. So I provide the tangency here. Okay, now it becomes green. So it's all green, right? So that's the how things are supposed to continue. I will move to the lower part. Again, provide the tangents. Oh, I don't have a line here yet. Okay, so let me draw a line between here to there. Okay. Then draw a line between here to there. Okay. And then I provide a tangent constraint. this line with this arc, this line with that arc, this line with that arc. Okay, so now all geometry that I have so far are all green. Any questions so far? Okay, so it seems like too easy, right? But there are catch. So now, well, this has to be arc, not a circle. This has to be arc, not a circle. These geometry locations are all perfect, but you'll be surprised when I do, when I have a trim. Okay, so I will have a trim command to remove this line, this line. Now suddenly this become yellow. Why? While I was removing this circle or changing the circle or trimming the circle to the arc, the tangency conditions are gone and radius conditions are gone. That geometry is good as it is, we build, but those constraints are gone. So we need to make it again to make it green. But you need to provide the constraint in the original geometry because you need to find a good location to start with. So I will trim them. I will trim them. And then I will trim them. Okay, so now even if they don't look like a green, but you know that they will be green if you provide the same constraint that we assigned before. So let's go again with the constraint. Again, tangency, right? So we have a tangency between this one to that one, this one to that one, here, here. All right. Okay, now in the dimensions. So this dimension with respect to this one, well, all dimensions are correct because we already find a location to satisfy those dimensions. Just to repeat the same thing that we did before to provide the dimensions that we had before. So I want to show you, so far, nothing has been changed. They are all yellow, right? That's the beauty of the constraint geometry, because once you provide, write the constraint, okay, then everything will change to be green as it's supposed to be. So where else do we need to change? I have dimensions. Okay, I have radius. Okay, so the radius of this one is missed. This is supposed to be 3. This is supposed to be 3. Now suddenly all of them become yellow, right? Green, I mean. Why this one is not? Okay, so what I will do is I will.
You have to make that. You have to make that point that you're just on with the horizontal line.
Mm-hmm. So another one that I want to emphasize is that when you create a circle is by definition it doesn't have any starting point and ending point, but in the geometry point of view, they have to start at one point and they have to end at it. So the point that you click, it will be your starting point. So this is actually 2 arcs, not the 1 arc, which I don't like it. So I will delete this. And then I'll make a 1 arc starting from the same point. Okay. And then I'll provide constraint again, tangency. Okay. And then radius 4.2. So now it's all green. Okay. All right. What else we need to do? We need to make the inner cutouts. So let's do, again, I will choose the point and then create circle. And then I will choose another point, the circle. And then I will make a line. I will intentionally miss this point, okay, like this. Then draw the line. So in here, what you have to worry about is I automatically Abaqus put the H constraint here, because when you draw it, it is a straight line in the horizontal line. So Abaqus consider, oh yeah, the user may want to draw a horizontal line, so I will keep it horizontal. No, it's not, because I will change the dimension later. So what you have to do is you have to remove the automatic constraint that Abaqus created, which is not what you want. So you remove them. I don't want them to be horizontal. Instead, I want them to be tangent, okay, with the circle. Like this. So you have a tangent conditions. Now I need to fix the location of the center. So here, with this one, 8. Is it 8? 8. Okay. I must pick the perfect positions. Okay. And this one will be 31.5. Okay. All right. So why they are not green yet? Anybody? Why they are not green yet? I didn't set the radius. So let's put the radius. This one's supposed to be 1. And then this one's supposed to be 1. So now everything is great, okay? But you, as we experienced before, if you trim, the green color will be gone because now the radius is removed, right? So I will need another dimensions with 1, and then another dimensions with 1. Okay, but still it's not green. Why? When I create a circle of radius 1, it is on this construction line at the center. But when I change the circle to the arc, that constraint, the coincidence constraint is gone. So that's why it doesn't look like what it is. So if you look at the project statement document, there is a 0 dimensions between the center of this arc and then also the horizontal construction line. That's possible. That's one way. But the other way that I would do, I mean, there is no single way to do it. There are many different ways to do it, right? So you can create an arc starting from, if you choose the center point here, then it will generate the point at the point. And then you go this. Okay. Also, you create here. Now you create an arc, and then you provide a tangency. And then you provide the radius. Okay. Okay, so the tangency is not made it. Okay, then I have to do this one. So this is the one way you fix this point vertically to be 0. Okay. And also this point to be vertically 0. Sorry about that. The one that I missed is the horizontal dimensions. So I put the horizontal dimension between this one and that one to be 8. And then this one to that one to be, all right, now it's good. So these are all green colors now. So that's the geometry, the fully constrained geometry. Are there any questions?
Could you, after getting out of this view, could you hit the info button to get the volume?
Oh yeah, okay. So that I will get that later, okay?
Okay.
So this is the geometry that I make it. Are there any question on the constrained geometry? Okay, then I will move on.
Dr. Kim,
Yes.
if your constrained geometry has the horizontals on the center cutout in the picture, but then you change those, you'd obviously have to change that constraint to make the hole larger. Is that fine, or if the H's are in the picture for the geometry, should we go back and change that?
Yes, you can delete it. Okay.
But if they're in the picture that we took, like I did this a while ago, so my picture from the geometry was taken with the H's in there. Is that not right then?
Which one? The cutout has H or the center line has H?
The cutouts have an H.
If you cut out the H, then if you change the dimension, it will not change like this.
Right. So then I need to redo my image
you need
for
to read the constraint. Yeah. So
Okay,
if you make
you.
the initial design with a not fully constrained, your first 3 tasks will be fine. The only problem is that the last task, when you change the design, it will not change the design properly. Make sense?
Yes, sir. It was fully constrained. I just used the horizontal constraint.
Yeah, it is possible. There are different combination of constraint may give you fully constrained, but your design may change differently than what I expected, right? So this is what the designer put their intention in your model. If I don't put the proper constraint, then when I change something, then they may not change properly. So, but just for fun, let's say I delete this one. So it's not fully constrained. Let's say if I change the dimension of this one, okay, to be 2. So you change dimension to be 2. How do you want this one, the entire cutouts will change? Do you want them to be moved all together, or only the right cutouts have the increased radius, or left dimension the same? That all depends, okay? So in this case, if you change this one, it moves only that one. But let's say if I have horizontal constraint. So if I put the horizontal constraint over this line, now it's fully constrained, right? It's fully constrained. Now if I change the dimensions of this one, let's see what happens. That's your design intent. Because if I change this one, it needs to maintain horizontal, then everything has to move up. So if that's your intention of the design, that's fine. But if your intention is, no, they may not maintain, but if I change the radius on one corner, then the other corner does not change, then you need to do differently. So depending on how you want to design to be changed, you need to provide a different constraint. So right now we decide to keep this one and that one to be separated. Any other questions? All right. So we are done. So this is your initial geometry. When you want to change it, you can go back to sketch. So the gray area is what the solid look like, and then the greens are your current boundary. If you change any of those, like this, and then you finish the sketch, I want to increase the radius to 3. Nothing has been changed because you did not regenerate it. So you need to right click, choose the option regenerate, then it will regenerate the model. Go back, change back to 1. And then regenerate it. Okay. All right. Creating the material. I think this is a trivial work, so I will not not go too much details. And the mechanical property, Young's modulus. I don't remember what value that I asked you guys to do it. 10 to the 6.
It was 206.8 GPA.
A GPA, right? GPA, okay. But you need to convert it to the unit that you're supposed to use. Important thing is you need to provide the density here, okay? Density, so that when the density is given, it will calculate what the mass. Without having density, it will not calculate the mass, okay? Create a section, solid homogeneous, and then it will be plane stress thickness is 1, and you assign the section. Okay, so this you made a section. I'll go a little bit fast because this is a repetition of what we did before. So quad dominant model, and the meshing option is free. You are if you want to be structured, then you need to partition the structure in the 4-edge simple geometry. But now the technology is advanced. If you choose the medial axis option, it will work well too. Element types, we'll use the plane stress element, plane stress, turn off the reduced integrations, linear formulations for the Q4 element, right? And then seed, 0.6 is the smallest one, right? 0.6. Let's use 0.6. I didn't change anything else. Then it will show us that on the boundary, these are approximately the position of the nodes that you created. So in the bottom one says it generates 845 elements if we use the element size of 0.6. Okay. Right.
Professor, did you use the median?
Yeah, medial axis options.
So you went to mesh, element type?
No, mesh control. The medial axis options. Okay, if you want to try advanced, let's try.
I was just looking at it, and mine just looks different. Mine has 997 elements versus yours.
Yeah, it could be. My cut is much bigger, longer than yours, right? This is bigger than initial design. The internal cutouts are much bigger now compared to the initial design that you're supposed to do.
Oh, did you use a different? Did you not use radius 1?
I used the radius 1, but the length is much longer than yours.
Oh, so you didn't use the dimensions that you stated in the problem.
This is not the initial design problem. Yeah.
Oh, okay.
I don't want you to make the exact copy of it, so I make it choose different dimensions. All right. So this is when you create it by pre-mesh, but if you use the medial options, medial axis options, the mesh looks like a much regular. I mean, a lot of them are actually square elements, right? So it works better in this case. I will create the assembly of the instance. Okay. And then you create the step of linear perturbations, static. Okay. All right. And then I go to interactions, and then I create the reference point at here and there, because there's a space that they don't have any nodes, but you want to apply boundary condition at this point, so you need to create the reference point. And then you assign the constraint. So constraint is, first one is the MPC constraint between this one and then between this. So you can choose a pin or beam. It actually doesn't matter, but please choose the beam. And then make another constraint. Now this time you can choose the MPC also, but I will choose the coupling between this point and then surface So you create coupling. Okay. What else do we need? I think we are done here. Apply boundary conditions. So again, this is a no rule, but it's my preference. You apply the initial condition, you apply boundary condition in the initial step. And then I fix all 3 degrees of freedom. Whereas I apply load in the actual step that I apply. How much load to apply? Anybody remember it? 2789 minus, and then 5066. Okay. All right, you create the job, and you submit the job. Okay. So these are the deflection look like. So now you realize that if you look at the geometry, it's not simple bending. It's a little bit twisted, right? It's more like a stepwise deformation because you have a longer slit. So if I go back my model, then if I go back to my sketch, and then if I change the dimension of this one to be 27, okay. And then regenerate it.
Excuse me,
the mesh is
Professor?
already, yeah.
I'm sorry, I didn't mean to interrupt you.
Look right.
So I was looking at the constraint for the coupling on the right.
Mm-hmm.
So when it says the constrained degrees of freedom, should they have no constrained degrees of freedom? Or I guess I didn't understand that portion.
Okay, let me go back. So constraint here means, so control point is the independent degree of freedom. Mm-hmm. And then the surface is, nodes on the surface are dependent. So whatever I do on the control point, it will be distributed on my surface, okay? And then constraint meaning, what are the constraints? If I rotate that point, everything will rotate. If I move this point up, everything will move up. If I move this one to the horizontal, then everything will be moved horizontal. So these are U1, U2, U3 are what degree of freedoms are coupled with the control point. So what degree of freedom the control point controls. Make sense? Mm-hmm. So if you have only U1, mean it only controls the U1, right? Then if you apply the vertical force will not transfer to the structure. Only a horizontal force will be transferred to the structure.
Okay.
All right. What I try to convey is, now I change the dimension of the hole. And then I want to compare the result, the one that you see before, and then this new one. So do you see the little difference? The previous one was this vertical, the horizontal one was, this one tried to move like the stepwise, but now it moved like a bending. Right? This portion is rotated a little bit, whereas previously it was not. Why? Because right now, if the in the center cutout is small, then overall the token behave like a beam. But if this one get it longer, then the entire thing becomes more like the box beam. Okay, so that's why the shear modes come in as you increase the inner cutout size. Now, what else do you need to look at it? You want to look at the mesh property. So what you have to do is go to the tool, query. Query means I want to ask this some properties. And here you have a mass property. So if you click it, then on the bottom screen here, it says the volume is, since we use the centimeter, so it will be centimeter cube. And then where is the centroid? And then how much the mass it is. It is about 2.24 kilograms. So it's a small, tiny product. Also, if you click the node and you want to investigate the watt value of displacement at the point. So let's choose the reference point on the right here, right? That's your load application point. If you choose it, then it'll give you base coordinates, meaning what coordinate it was, and then scaled coordinates, and then deformed coordinates, and then unscaled. So this is a scale factor that you applied it. If you look at it, the scale factor is a 3.45. So the total displacement is scaled in the plot, is scaled by 3.45 times. That's a scaled displacement. But the deformed coordinate unscaled is without multiplying the scale factor. But unscaled display, that's what you need. This is your displacement, X displacement, Y displacement, and then Z displacement, which is supposed to be 0. So your vertical displacement will be 1.3 centimeter. That's what it is. So unfortunately, you can estimate this displacement. You can estimate the mass property, but when you click the mesh, element, let's choose the element. So this is the element that I want to investigate. Then it shows what is the von Mises stress, not averaged. Okay, so at this point, it will not give you any average stress. It will give you 15,000, 17,000, 15,000, and 17,000. So if you remember, there is 4 Gauss quadrature point, right? 1, 2, 3, 4. These 4-point stresses are this. Now remember, this is not the edge of the element. So the actual extrapolated stress on the surface will be 21,000, as you show on the von Mises plot. But in the interaction point, it is 17,000. So it is 17,000. If you extrapolate it, that's 21,000. So that's the difference in the stress value. All right. At this point, it is some students try to make the 3 different element types at the same time, but it's going to be very hard in this case because we only have 1,000 node limit, so that it will not give you all mesh at the same time. So what you have to do is you need to go back to the mesh, and then you need to change the element type. So for example, in the Q8, you need to have a quadratic. Turn off the reduced iterations, and then seed. I don't think you can do it with a 0.6, so that you increase the seed size, and then create a part. Now, didn't I click the media axis? Yeah, okay.
I'm sorry, Professor. Did you say you can't do it with just 0.6?
Let me try. Let me try 0.6.
Is it supposed to be 0.66, Professor?
0.67.
Oh, 0.67.
Yeah, 0.67.
I was going to ask you that during office hours. I was having that problem where it was saying you had over 1,000 nodes when I did 0.6.
So it is a 6.8. Yeah. So 685 elements has been created. What you can tell is, now if you look at the move on the element, so these red ones are your nodal, so that you can see there is a node in the middle, right? So these are indicated that you are using the Q8 element. So let's submit this one. So now go back to the mesh. I will delete parts.
Question, how come you're using quad dominated, but in the problem statement you tell us to use quad?
Okay, so mesh control, let's use a quad redirections. Element type, only quad element, and the mesh part. So that's the only quad only, right?
Yeah.
Yes. I ask you to use only quad, not quad dominant.
Professor?
Okay. Yes.
If you do a job that you made for a specific mesh size,
No,
but don't
it doesn't
resubmit,
work. It doesn't work.
oh, it doesn't work.
Yeah. So what I'm guessing your question. So let's say you make a Q4 model, you create a job 1, and you make the Q8 and create a job 2. It doesn't work.
Okay.
So whenever you submit a job, it will be submitted the job based on the current model, not the previous model that you have. So unfortunately, right now, I wish what I can do is, if you have a more available nodes, then I will make you 4 tokens. You make it one model and the 4 copies of instance, and then make a Q4, CST, LST, and Q8 to see the results. But unfortunately, you cannot do that. Okay? The stress is much higher, it's 226,000. Previous one was low, about 21,000, because of the stress is high. Okay? So
Can you
yes.
repeat that? Sorry. You said if we submit job 1 with a one node type, and then job 2 with another node type, and job 3 with another node type, the job 1 is invalid after we change our nodes?
It doesn't. The ODB file will be there. So let's do it. Let's do it just to make sure that we are on the same page. So I go to the C, delete mesh.
And now do say like triangular.
No, let's make it. Let's make linear quad, right?
Okay.
Linear quad. Now I make mesh. Okay, so this is a linear model. I don't have any corner node. I don't have any middle-side node. And then I will create, edit. I will make it as rename. Okay, so I will name it as a Q4. Okay, and then I submit the job. Okay, now then I go to mesh, delete. I need to go part. Since I create the mesh on the part, and then change the element type to be quadratic. And then make mesh. So let's check it. So there is a mid-side node, and I create the second job, name Q8, and then submit it. Just to be careful, the Q4 model is already gone. You don't have a Q4 model, right? You delete mesh and you make the Q8 model. So Q4 model is gone. Q8 model is the current model. But what you have is, you have ODB file. ODB file is the result. So you have a Q4 ODB file, and you have a Q8 ODB file. I will show you in the point here. So this is the Q8 ODB file that you just made it. That there is also Q4 ODB file that was here before I made it. So you have results. You don't have a model. Okay, so you can see the only result all along. Let's go to results. Okay. So this is the Q4 results, 21,000. Okay. Now you go back to the model and you click the Q8. Okay. Now you plot the stress. This is Q8 result. So you can have a multiple results, but they don't. Your model, the current model that you have here is only Q8 model.
Okay, that makes sense. Thank you.
So you can make a four jobs of one LST, one CST, one Q4, and Q8. You can look at the results.
That's all we need, though.
It'll save the results.
Yeah, you
right.
save
So that's all we need, though, for the task, for task 4, right? Because we're comparing the accuracy of our results.
Now, in the result, what you can do is if you open the output database, see you have a job 1 that we created before and a Q4 and Q8, right? So the one has underlined is the current model. So you can go to here, you read the result, that will be Q8 results. If you double click Q4 and you apply it, then it will be Q4 results. So you can actually have a multiple, and then actually you can close it. If you don't need any result, you can close it. Whenever here, you right click and go to the results, that means it opened the ODB file. That opened ODB file is over here.
Would it work for different shapes?
Different shapes. Well, I can try. I can try. So let's make.
Or different sizes for that matter?
Yeah, I mean, I would change the dimensions.
Oh no, I meant like different size. Like instead of doing 0.67, do 1 or 1.67.
That definitely will work. And I'm sure that if you change the design, let's say this is 13. Even if you change the design, I'm sure it will work, because the ODB doesn't relate it to anything about the CA model. You can actually. So this is your model, and then you make a mesh. And then you create a new job. Say new geometry. And then you submit the job. So if you go to results, now you have a Q4, Q8, and a new geometry, right? So this is your new geometry. Just to look at the cutout size, it's smaller. But if you go to the ODB, this is a bigger, right? So in the different geometry, you can have a different ways. Another one. Now, if you go to the folder, there is a file called INP. New geometry.inp. This is actually input file. You can actually modify. This is basically not the model, but what are the nodal coordinates? So these are nodes. Okay. You have a nodes of, you have a lot of nodes here, because you have 2100 nodes, and this element. And then you provide MPC boundary conditions, coupling boundary conditions. So whatever you did in the CAE is converted to the input file. Sometimes you don't have a model, but you only have an input file. You can still run it in here. Double click the job. So what it says here is, I will create a job for source is model. No, I want to use the input file to create the job. So what input file do you want to create it? I will use, let's say, make something else. Well, bike frame. How about this one? Your bicycle frame. Okay, this is a completely different model, right? The project 1 actually. So now I have a new job called bicycle frame. You submit it. Hopefully that input file is a good one that you can finish the results. Running. Complete. So if you go to results, now you see the bicycles. So this is Tocom, and this is the bicycle. You can see the deformation of this one. So if you have a model, you create a job, you submit it. But if you don't have a model, if you have info file, or if you have to modify info file directly, you can also create a job based on info file and run it, and then look at the results at the this visualization model. Okay. Any other questions? I think this is a good time to stop the class, and then we can move on to the office hour if you don't have any other questions. Okay, then I will stop recording, and then we can move to office hour.
Hey, Professor, can we
Yeah.
continue the tutorial in office hours? Just like roll over to office hours?
Well, I'm pretty much done. What you need is now you need to change the element type and then geometry, etc. Right? There is nothing more I need to do. Do you think I need to do more?